DHCPv6 or Dynamic Host Configuration Protocol for IPv6. This is not the 6th generation of the DHCP. Actually, this is the Dynamic Host Configuration Protocol for IPv6 in compare with the DHCPv4 that is for IPv4. Okay, let me to talk about the DHCPv6. You know that in previous video we have learned about the stateless address auto configuration, one of the IPv6 address assignment methods that we have. Look at here. About the IPv6 address assignment, we have two a major method. The first is static and the second is dynamic method. Okay, and we have learned about the static method. You know that in a static IPv6 address assignment we can assign IP addressing, IPv6 addressing with static configuration, or with static with EUI64 or extended unique identifier 64 bits we can configure the IPv6 addressing. Also about the dynamic methods, in the previous video we have learned about the stateless address auto configuration, and you know that in the stateless address auto configuration a client, okay, should send the RS message. Okay, after that it will receive one RA message or router advertisement message contain the prefix of this network. Okay, and after that this is included with the IP link local IPv6 address of the default gateway. Actually the client now has its IPv6 address, can create its IPv6 address with the for example random method or with the EUI64 method, and also it has the default router or default gateway IPv6 address. But you know that in the networks we need to have more information. For example, assume that you need to resolve the name, the URIs to the for example IPv6 address. You need DNS or domain name services. Okay, and now the client doesn't know anything about the DNS. Also maybe some clients need to take the addressing of some other services such as the network time protocol or NTP, such as the FTP file transfer protocol or TFTP trivial file transfer protocol. Actually we can say that in a stateless address auto configuration we have only the IPv6 address, the prefix length, and also the default router IPv6 address, and because of that maybe we need to have more IPv6 address, more services IPv6 address. Because of that we can use these two methods, stateless to DHCP and also stateful DHCP. I will talk about both of them, but first we should know about the process of the DHCPv6 in the IPv6. Here we have some differences between the DHCPv6 and DHCPv4. Because of that, first we should learn about the process of the taking IPv6 address in DHCPv6. Okay, and after that we can talk about the stateless DHCP and also a stateful DHCP. Actually all of the processes that I am going to talk about them, all of the configuration now related to the stateful DHCP or the normal DHCP you have used before in the IPv4. A stateful DHCP equivalent to the DHCP in IPv4. Okay, but in a stateless DHCP we have some differences. Let me to talk about the DHCPv6 process. You know that when we are using the DHCP, actually we need some IPv6 address. Our IPv6 address, our prefix length, after that the for example default router, then DNS server, then a TFTP server, maybe the for example domain name and some other things. Okay, because of that we need to use DHCP. DHCP can be configured, can be available on one server. For example, assume that you have one server and in this server you have enabled the DHCP v6. Okay, this is the DHCPv6 server. Or if you want, you can configure one router, normal router, as the DHCPv6 server. Or if you want, you can configure one MLS or multi-layer switch as the DHCPv6 server. Actually all of this for example solutions are available. In this video I'm going to talk about how we can configure the DHCP on one router. Okay, but you can configure exactly same commands on the MLS. Because of that, here we don't have any difference. Okay, let me to start to talk about first the process of taking IPv6 address and some other addresses in the IPv6. This is a four-way process or four-step process, such as the DHCPv4. In DHCPv4, let me to review. First, we should send DHCP discovery. After receiving DHCP offer, we should send DHCP request, and finally we will receiving the DHCP acknowledgement. Okay, in DHCPv6 again we have four steps. The first step is sending the DHCPv6 solicit message. Okay, you know that here we don't have discover message. This is a solicit message, and with the solicit message we are trying to find the DHCPv6 or all DHCPv6 servers. You know that in IPv6 we don't have broadcast. Let me to review the IPv4. In DHCPv4, okay, as you know, all of the messages of the DHCPv4 are using the broadcast. For example, when the PC1 sending the DHCP discovery, okay, it should send this DHCP discovery to quad 255. Why? Because first PC1 doesn't have IPv4 address, and after that the PC1 doesn't know about the IP address of the DHCP. Actually, it can only send broadcast, and because of that the PC1 is using broadcast. The source IP is unspecified IPv4 address quad 0, and then the destination IP is the broadcast in hope to find the DHCP server. Okay, but in IPv6 we are using a more efficient method. Why? Look at here. In IPv6 we have one specific reserved multicast IPv6 address for all DHCPv6 servers. This means that when you are enabling on one device, such as a server, such as a router, such as an MLS, okay, we will, as a DHCP server, we will have this IPv6 address on that for example device. For example, you know that when we are using one IPv6 host, okay, for example the computer, the router one, we have this IPv6 ff02:1, this multicast address on that host. Also, if you are enabling one router for IPv6 unicast routing, you will have this IP address ff02:2 on the interface of router. Now, if you enable the DHCP on the interface of router, now we have another IPv6 address ff02:1, okay, colon 2. This is the reserved IPv6 multicast address for the DHCP. Because of that, the client doesn't need to broadcast at all. We don't have broadcast in the IPv6. Okay, we can send directly our request, okay, our solicit to the ff02:1:2. Also, you know that each client has a link local address. Because of that, in the source IP we can use the link local address. Actually, a client sent this message in an attempt to locate a DHCPv6 server, and you know that because this message destination IPv6 address is ff02:1:2, only all of the DHCPv6 servers in these networks are receiving this and are accepting this solicit. Then the R1, the DHCPv6 server, actually should send the advertise message or DHCPv6 advertise message. This is the response of the DHCPv6 server to the solicit message, and this is a unicast message, and here we are sending this advertise to responding the solicit message. Again, here we are offering some IPv6 addressing and some other useful information. Okay, after that the client should send the request message. This request confirm that this client needs to, and for example wants to receive this IPv6 addressing, and finally with the reply message the server finalize the process with the for example DHCPv6 server. Actually, we can say that here we have a similarities between the DHCPv6 and DHCPv4, but also we have some differences. For example, the first differences is that here we don't use the broadcast. We are using the more efficient method, the multicast, reserved multicast IPv6 address. After that, About the functionality of this message, we can see some similarities, but about the name of this message, we have some differences. For example, now we don't have DHCP discovery, we have DHCP solicit. We don't have DHCP offer, we have DHCP advertise. But about the request, in the IPv4 we are using